Hello everyone, I welcome you all to Physics Wala, and in this session we are going to discuss the next portion related to your most important as well as very interesting chapter, that is mole concept, and this is lecture number 3. In this lecture we are going to discuss about lots of concepts as well as lots of questions related to the calculation of mole. Now in the previous part we were discussing about the certain concepts related to empirical formula. So basically in this session we are going to start with the next part, that is a molecular formula as well as its calculation. Definitely we are going to revise the entire part related to empirical formula also. I gave you one question, so definitely we are going to discuss that question also. Then we are going to discuss about the next part, which is laws of chemical combination, and two major concepts. First one is the concept of stoichiometry as well as limiting reagent, and trust me, these two parts are actually very important. I hope this part is clear. Now basically this session is dedicated to all the questions, all the important concepts related to your chapter, which is mole concepts. So let's start with the first part. We were discussing about the empirical formula as well as its calculation, and I told you, you just have to remember 3 simple steps. First of all, you have to look at the information whatever is given to you in the question. Now this information can be given in two forms. First one is the mass percentage, or it may be possible that given information is given weight of the elements, which is W generally. Okay, you have to just look at this particular information. Now from that information you have to convert the data into number of moles, and how you can deal with it? It's very easy. So N will be equal to given weight divided by molar mass. If you have the information about given weight, it may be possible that question is saying about the mass percentage, then again you can calculate this particular part by mass percentage divided by the molar mass of that particular element. Now you have to convert the entire data into simplest ratio of the moles. So just pick the lowest mole value and divide the entire values with the lowest value, then you will get the simplest ratio of the moles. It may be possible that you will get the number in fractions, it is not a whole number, so you have to convert that data into simplest whole number also. So this is the additional step if you are getting the mole ratio in the fraction part. Okay, now talking about the table formation, I told you this information will be given to you, all the elements which are present as well as their mass percentage or given weight, and this part is already known to us, which is the molar mass. Then you have to divide that entire part to calculate the number of moles. Just pick the lowest value and divide each part with the lowest value. It may be possible in this step only you will get the whole number part. If not, then you have to convert the entire data into whole number. I hope this entire step is clear to everyone. Now talking about the next part, we all know that the empirical formula talks about the minimum ratio of the moles which are present, or you can say the simplest whole number ratio of all the elements which are present. But if I talk about the actual formula is known as the molecular formula. So the formula of compound which gives the actual number of atoms of various elements which are present in one molecule of that particular compound is actually known as your molecular formula. So this is the exact information. Now how to calculate this particular part? You just have to do one additional step. So generally this molecular formula is basically very easy to calculate. This molecular formula is actually empirical formula multiplied by a specific number, which is N. Now what is N? N can be calculated with the help of two informations. First part is molecular mass and second part is empirical formula mass. So N you can easily calculate with the help of this particular formula. Now the question is, sir, how can we calculate this particular part? So always remember, molecular formula will always be given to you. This will always be given to you in the question, and this particular part you have to calculate, because you know how to deal with the empirical formula, how to predict empirical formula, and from empirical formula it's very easy to calculate the empirical formula mass. If you divide the entire part you will get the value of N, and then N multiplied by empirical formula will give you the value of a molecular formula. Now coming back to the question which we were discussing in the previous part, we are going to discuss that question related to ascorbic acid. Now if I talk about the benzene, we already know its empirical formula is a CH, because the actual formula is a C6H6 and the minimum ratio is CH. So you can see empirical formula is a CH, when I multiply this entire part with 6, we will get the actual formula, which is a C6H6. So in this case, you can see the N value is actually 6. For second part, acetylene, you can say this N value is actually 2. When I multiply this entire part with 2, you will get the value which is a C2H2. That is the actual formula of the compound. In the same case of glucose, you will get the value as a 6. When you multiply the entire part with 6, you will get the actual value as C6H12O6. For H2O, this value is going to remain same, that is 1, because its empirical formula and molecular formula are same, because the minimum ratio is 2:1 in both the cases. I hope the entire part is clear to everyone. Now, talking about the same question which we were discussing in the previous lecture. Question says vitamin C, which is ascorbic acid, contains 40.92% carbon, 4.58% hydrogen and 54.50% oxygen by mass. The experimentally determined molecular mass is 176 AMU. I told you this information will always be given to you, which is molecular mass. This is already given. Now you have to calculate the molecular formula. So to calculate the molecular formula, first of all you have to calculate its empirical formula as well as empirical formula mass. Then only you can proceed for the next part. So in this case, I can say we have carbon, hydrogen and oxygen. So we have a first part which is carbon, then we have hydrogen, then we have oxygen. If I talk about the percentage, 40.92, 4.58. So this is a 40.92, this is a 4.58 percentage, and remaining part will be 54.50. This is 54.50 percentage. Okay. So these are the elements which are already given. This is the mass percentage already given to you. Next part is you have to calculate number of moles. How you can deal with this particular part? This 40.92 divided by 12. This 4.58 divided by 1. And this is 54.5 divided by 16. Okay. I hope this entire part is clear. You can solve this entire part. So we have this information here. Okay, I'll try to make a table so that this will be clear to you. So this is the first part. Okay, this is your second part given. This is the third part. There is a fourth part also which you have to calculate. Now the fourth part will be in this particular situation, that is simplest ratio. Okay, fourth part will be simplest ratio and last part will be simplest whole number ratio. Okay, so this is the last part. I'm just trying to make a proper table for you guys. Meanwhile, you can solve this entire part. To let me know the final value. So we have this information which is already given to us in the particular situation. So you can say this will be equals to 4.58 only, first part, and in this case 40.92 divided by 12. So I am just solving it directly. Because we have a limited time frame, so that's why you can solve it by yourself. We have 40.92 divided by 12, so that will be 3.41. This is 3.41 in this particular situation. Now if I talk about the last part, in this case we have a 54.5 divided by 16, which is 3.40625. Oh, very close, 3.40625. so this is the final value. Sorry, I'm doing this calculation very fast because we have a limited time frame, but you can solve it by yourself. Okay. Now in this case, you can see we have to calculate the simplest ratio. So the lowest value is this. So I can say we have 3.41 divided by 3.40625. So I can say approximately that will be equal to 1. Next part, in this case we have a 4.58 divided by 3.40625. that will come out as approximately 1.33 if I'm not wrong, and this part will be 3.40625 divided by 3.40625, that will be equals to 1. Okay, now this is not the simplest ratio, so what can I do? This is 3.4 multiplied by 1.33.4 and 1/3 of this value. I guess that will be 1.5, not 1.33, that will be 1.5 approximately. That will be 1.5, I guess. Okay, let's try to solve this. So simplest ratio is I am multiplying this entire part with a 2, so we'll get this value as a 2. This part I am multiplying with a 2 again, that will be 3, and this part multiplied by 2, that will be 2 again. So we have the formula now. No, I guess that will be 1.33 only. 1.33. I'm not sure because we have to calculate this entire part by ourselves only. Just let me know if that is 1.33 or 1.5. So 1 multiplied by 3, that will be 3. Let's say 1.33 multiplied by 3, that will be approximately equals to 4, and this 1 multiplied by 3 will be equal to 3. Okay, so we have the answer with us, which is C3H4O3. Okay, so this is the empirical formula of the compound. Now we have the empirical formula. It means empirical formula mass from that data will be 36 plus 440 plus 48, that will be 88 U. Okay, so this is the part we have already calculated. Now the value of N is molecular formula mass, which is given to us, divided by empirical formula mass. So this part is 176 U divided by 88 U, that will be equals to 2. Okay, so we can say that molecular formula will be equal to N multiplied by empirical formula. If we put the value N is 2 in this case, multiplied by C3H4O3, so that will be C6H8O6. Do we have any answer related to this particular part? I guess yes, we do. C6H8O6. Yeah, option number B is already given to us. If you are putting this value as your first part answer, which we were discussing in the last class, that is the empirical formula. This is the empirical formula, but this is the actual molecular formula of your vitamin C. I hope this entire calculation part is clear to everyone. Very straightforward calculation, nothing fancy. Okay, now talking about the next question. This question is basically my favorite question from NCERT. So basically this question is indirect version of your empirical formula part. Okay, now how to deal with these type of questions? Just look at the information very carefully. Okay, this is a very important question. This is a very important question. Okay, so some part I'm going to do, some part you have to do with me. Question says a welding fuel gas contains carbon and hydrogen only. So we are talking about hydrocarbon. Definitely in this question we have the species which is hydrocarbon. Okay, now this question has two parts. First information is burning a small sample of it in oxygen gives 3.38 gram carbon dioxide and 0.69 gram of water and no other products. So let's say our hydrocarbon in this case, whatever hydrocarbon we are considering is CXHY, because I don't know the formula, not its empirical formula, not its molecular formula. I don't know anything, but I know one thing: when this hydrocarbon actually reacts with oxygen, only two products are going to be formed, which is CO2 as well as H2O. Okay, now either I can balance this equation or there is no need, because we know that in CO2 whatever carbon is coming, is coming from the hydrocarbon, and just like that in water also, whatever hydrogen is coming from this hydrocarbon only, because they are combining with oxygen only. Okay, now the information about this entire part is given, that 3.38 gram of carbon dioxide is present, so we can say W of a CO2 is given to us, which is 3.38 grams. W of H2O is also given, which is 0.69 grams. Okay, so this information is already given to us. Now from that particular part, can we calculate its mole? Yes, very easily. We can say, or much simpler version, we can say that whatever carbon is coming from the hydrocarbon part. So we can say that whatever CO2 we have, its molar mass is 44. So we can say 44 gram of CO2 contains only 12 gram of carbon. This part you already know, because the molar mass of CO2 is 44 gram, 12 plus 32. Now you can say this 44 gram only contains 12 gram of carbon. If I talk about 1 mole, so I can say that 1 gram of CO2 will contain 12 divided by 44 grams of carbon only. It means I am using the unitary method. It means 3.38 gram of CO2 will contain how much carbon? So you can say that 3.38 gram of CO2 will contain 12 divided by 44 multiplied by 3.38 grams of carbon, and this entire carbon whatever we have calculated is coming from this part. So you can say this is the first situation. Now the second situation is again very easy. What you can do, same with this particular part, you know the molar mass of H2O is 18 gram. It means that 18 gram H2O actually contains 2 grams of hydrogen. Yes, very true. It means 1 gram of H2O will contain how many grams? It will contain 2 divided by 18 grams of hydrogen. Now we have 0.69 gram of water produced. So it means 0.69 grams of H2O will produce 2 divided by 18 multiplied by 0.69 grams of hydrogen. And this hydrogen is coming from this hydrocarbon part. Okay, can you solve this entire part so that we know that we have actual amount of CXHY? What is the actual amount we have taken in this particular container, so that the entire part of carbon is converted into CO2 and entire part of hydrogen is converted into H2O. I hope up to this portion everything is clear to everyone. This is the most important step. Basically, we are also going to deal with this type of question in organic chemistry, which is your first part of organic chemistry, some basic concepts, some basic principles and techniques of organic compounds. In that case, you can see there is a particular method which is known as Liebig's method, which talks about the percentage of carbon and hydrogen present in the given compound. So this is the first situation. We know about the entire part. Now the second part of the question. Second part says a volume of 10 liter measured at STP of this welding gas is found to weigh 11.6 grams. Calculate empirical formula as well as molecular mass of the gas and molecular formula. So basically this is the entire summation part of your chapter. Now from that part we know the percentage of carbon, we know about the percentage of hydrogen. What we can do, we can directly calculate the percentage of a carbon as well as percentage of hydrogen in a very simplest manner, or else what we can do, we can calculate the percentage by another method also. But here I am going to talk about the same formulation, the table formulation, because that part is already clear to us. So this is the first step. Have you calculated this entire part? I hope this part is clear to everyone. Now to calculate the amount of a CXHY, because if we talk about the percentage of a carbon, we know the weight of carbon divided by total weight of hydrocarbon multiplied by 100. That we can do, first part. And in the same way, for percentage of hydrogen, what can be done? We can say that weight of carbon divided by total weight of hydrogen multiplied by 100. By this we can calculate percentage of hydrogen and percentage of carbon. This is one method. So you can calculate this additional step and put the value in the table. So I'm going to make the table again. Very simple part, but quite interesting. Okay. So in this case, we have the first information about the elements, which are only 2 in this particular case. Then we know about their either mass percentage or weight percent. Then we have to calculate the number of moles in this case. Then we can talk about the simplest ratio. Then we can talk about the simplest whole number ratio. And I am going to write down this particular part here and this part here. Okay. Okay. Now the first situation is elements. In this case, you have elements which is carbon and hydrogen only, because we are talking about simple hydrocarbon. Next situation is either percentage mass or given weight, either this part or this part. Okay, because I told you, you can calculate the entire part very easily. Now the next part, in this case, you can talk about their molar mass, which you already know. In case of carbon, it is 12. In case of hydrogen, it is 1. Next part, you have number of moles. And last part is simplest ratio. Okay, if required, we will talk about the simplest whole number ratio also. Okay, now in this situation, either you can calculate this additional step by calculating the amount of carbon as well as amount of hydrogen, combining them together to calculate the total weight of the hydrocarbon, then put the entire part in this particular formula, or you can directly put these two values in the given weight. So I am preferring this particular part because we don't have to deal with the additional step here. So we can say this part is 12 by 44. This is 12 by 44 multiplied by 3.38, I guess. Yes, 3.38. That will be 3.38. This part we have already calculated. So in this question, this information is not given, but we have to calculate this part. That's why this question is quite interesting. Now next part is 2 divided by 18. We have 2 divided by 18 multiplied by 0.69. Okay, now what you have to do, you just have to calculate the number of moles. So 12 multiplied by 3.38 divided by 44 multiplied by 12. So this is going to be cancelled out. Then we have a 2 multiplied by 0.69 divided by 18. So that will be 9. So we just have to solve this entire part to calculate the number of moles. So I gave you one information related to the simplest part. If you don't want to calculate the mass percentage, which is the additional step, you can directly use this information, because I told you in question you can find two informations, either the mass percentage or its given weight, which is already given in the question. So what can we do? We can solve this entire part, which is 3.38 divided by 44. I'll try to do that particular part. 3.38 divided by 44. That will be 0.768. That will be 0.768. I know this is going to be the lower value because this is 0.69 divided by 9. 0.69 divided by 9. That will be 0.0766. That will be 0.0766. Okay, so we have the first part, which is 3.38 divided by 44, which is 0.0768. This is 0.0768. Okay, so first part is 0.0766, 0.0768. So these are approximately same value, approximately. So I can say the simplest ratio is 0.0768 divided by 0.0766. That will be approximately equals to 1, and this part is 0.0766 divided by 0.0766. that will be exactly equals to 1. So we know that the ratio is already simplest whole number ratio. So its empirical formula is CH. This is the first part. From that part I can say that empirical formula mass will be 12 plus 1, which is 13 U. So this is the first part of this question. We have calculated its empirical formula as well as empirical formula mass. Now for the molecular mass of the gas as well as the molecular formula, again this part is missing. So we have to use the second situation. A volume of 10 liter measured at STP of this welding gas is found to weigh 11.6 grams. Now from this particular part, we are going to use additional concept. That is the concept of a mole in terms of volume. So we know that at STP, 1 mole of gas is having volume which is 22.4 liters. Okay, 1 mole of the gas means that the molar mass of the gas has the volume which is equals to 22.4 liters. So we know that 22.4 liters of gas at STP weighs m gram. Let's say this value, molar mass of the gas is, let's say, m. So which is the molar mass of the gas. This value I have taken, or you can take this entire part as x. Consider this part as x. So you can say this will be equal to x gram. Okay. So 1 liter of gas at STP weighs x divided by 22.4 liters, that will be in grams. Okay. Now 10 liter of gas at STP actually weighs x divided by 22.4 multiplied by 10 gram, and this value is already given. This value is already given. This value is actually equals to 11.2 grams. You can see the question. You can see the question that at STP 10 liter of this gas is found to weigh 11.6 grams. So that is very easy. So we can say that will be equal to x divided by 22.4 multiplied by 10 will be equal to 11.2. So you can say x will be equal to 11.2 multiplied by 22.4 divided by 10. Or you can use another formula, that number of moles are equals to volume of gas at STP in liters divided by 22.4. These are the number of moles. So N will be equal to, V at STP is already given, that 10 liters of this gas measured. So we have 10 liters divided by 22.4, first part. And you know that N is also equals to given weight divided by the molar mass of the gas. You know this formula. This is the additional formula. So you can correlate this particular part, that W by M will be equal to 10 divided by 22.4. From this part you can say that we have this value, that molar mass of this particular gas will be equal to, this W is already given in the question, which is 11.2 multiplied by 22.4 divided by 10. So you see we are getting same value in both the cases, same value in both the cases. Okay, so that will be the molar mass of the gas, which is x. Okay, so that will be your final answer. You just have to solve this entire part. Okay, now you know this S. Now you know the value of empirical formula mass. It's very easy for you to calculate the next part, which is the empirical formula of molecular formula of the particular compound. It's very easy for you to calculate the entire part. So from that part we can say that we have the information that N will be equal to molecular formula mass, which is the molar mass, divided by the empirical formula mass. This we have calculated. This part is also clear to us. So from that part, N will be equal to, we have 11.2 multiplied by 22.4 divided by 10 multiplied by 13. So this will give us the value of N, and from that part we can say that molecular formula will be equal to empirical formula multiplied by N. I hope this entire part is clear to everyone. If you want, you can do the additional step also here. by simply putting the values in this situation to calculate the mass percentage, and then put these values in the mass percentage, write down the molar masses, calculate the number of moles as well as their simplest ratio. You will get the same answer in this particular situation also. I hope up to that part everything is clear to everyone. Okay, so this is 11.2 multiplied by 22.4. I guess that will be approximately equals to 2. That value of n comes out as a 2, and yeah, that will be approximately equals to 2. I guess that will be approximately equals to 2. So we will get the molecular formula as 2 multiplied by CH, that will be C2H2. Okay, just cross verify the entire calculation and let me know the final answer. Okay, I hope this part is clear. This is a very interesting and very elaborated question because most of the informations are missing in this particular question. Okay, okay, now moving to the next part. This part is clear, this part is also clear, and this part is clear. Okay, just let me know the actual answer of this particular question. Okay, now we know how to calculate the empirical formula. Now we know how to calculate the molecular formula. We know about the calculation of mole. Now try to direct this equation, try to actually use this equation of a mole into much more convenient way, which is the actual reaction part, because you can find most of the questions which are actually related to the reaction part. So let's say we have a reaction, and in that case certain species are involved to form different type of products. How can we calculate the amount of product? How can we calculate the amount of reactant? For that part, the most important thing is to understand about the chemical reaction part. Now before chemical reaction understanding, we need to know what are the laws which are actually dependent upon these reactions, by which we can predict different type of reactions. So for that we have laws of chemical combination. Laws of chemical combinations talks about the actual analysis of reactions, because I can simply say no reaction is random. Specific amount of a particular reactant is going to combine together to form a specific amount of product. If they are that much specific, definitely they are working under a certain law. So this is the law of chemical combination, and in that case we have different type of laws. First law in that case is very easy, which is the law of conservation of mass, which we already know from our 8th 9th class. So law of conservation of mass simply says, if I am talking about any physical change or chemical change, definitely in this chapter we are going to be more concerned about the chemical change, but in physical change as well as chemical change, we can say whatever amount of reactant we have taken, this is going to be converted into exact amount of product. It means the entire mass of the reaction is going to remain conserved. So we can say in all physical and chemical changes, total mass of the reaction is going to be conserved. It means the mass of reactant will be equal to the mass of a product, and it has a simple analysis that matter can neither be created nor be destroyed. I know there are certain limitations to that particular law, but initially it was thought that mass is going to be transferable. We can say mass is going to remain conserved. So let's say if I talk about a very simple chemical reaction, that we have a methane which is going to combine with oxygen to form CO2 as well as H2O. In that case you can see we have a methane, carbon is 12, 4 hydrogen means 4, 12 plus 4 is 16 gram. So this 16 gram reactant is going to combine with 2 O2, means 1 O2 is 16 multiplied by 2, which is 32, 32 multiplied by 2, which is 64. So this part 64 plus 16 gives us the value of 80. So we can say that the mass of reactant in this case is actually 80 grams. Next part, if I talk about the mass of product, you can say CO2, carbon is 12, 2 oxygen means 32, so which is 44. So we have 44 grams CO2, and H2O means 18 for water, 2 multiplied by 18 for 36. So 36 plus 44 again 80. So you know in this case we have 80 grams also. So we know from that part that mass of reactant will be equal to mass of product. It means mass is going to remain conserved in the entire reaction part. I hope this portion is clear to everyone. There are certain limitations. In case of radioactive elements, this particular law is not applicable, because we know in that case that mass is going to be converted into energy. We have the equation E is equal to mc square. So that's why this law is having an extension also, which is known as law of conservation of mass and energy, because whatever mass is going to be converted into energy, that part is also going to remain conserved. Okay, so I hope this entire part is clear to everyone. Let's talk about a very simple question. Question says A gram of substance X reacts with B gram of substance Y to form C gram of substance R and D gram of substance S. This reaction can be represented by this particular situation. So we have X plus Y gives us R plus S. Now in this case, this information is given. We have A grams, this is B grams, this is C grams, and this is D grams. So we know that mass of reactant will be equal to mass of product according to law of conservation of mass. So we can say mass of reactant from this situation, that the mass of reactant will be A plus B grams. Mass of product will be C plus D grams. And we can say this situation is going to hold clearly for this law. So it means that A plus B will be equal to C plus D. I hope this entire part is clear to everyone. Very simple question related to law of conservation of mass. Now the next part is much more prominent law, which talks about the formation of compound, which simply says we are talking about the next law, which is law of definite proportion. It is also known as law of constant composition. Okay, so don't confuse, don't worry, both are same thing. Law of constant definite proportion as well as law of constant composition, both are same thing, and which simply says if I'm talking about a particular compound, we can form a particular compound by different methods. So whatever the source of a compound may be, it may be anything, like we can form a particular compound by any means. Whatever the source of a compound may be, their elements always combine in a fixed ratio of their mass, which simply says, let's say I'm talking about H2O. Let's say I'm talking about H2O. H2O is a compound and there are different sources. You can form H2O by the reaction of acid plus base, neutralization reaction, to form salt and water. So you can form water by this simple reaction. The source of H2O can be rain. This is the source, definitely. You can get the water from sea. So we have sea water also. Different sources are there. I can combine H2 and O2 to form H2O. So there are different sources of water, but each time if I'm looking at the water, I know the ratio of the mass of their elements is always 2:18, which is 1:9. This is always fixed. So whatever the source of a compound may be, their elements always combine in a fixed ratio of their mass so that the formula remains same. So this is not the situation that in first reaction, neutralization reaction, the formula of water is going to be different. In a second situation, if I'm getting rainwater, the formula of water is actually different. If I'm getting seawater, the formula of water in that case is different. The formula is going to remain same because their elements are always combining in fixed ratio of their mass. This is the actual idea about the law of constant composition. I hope this part is clear. You can take the example of CO2 also. There are enormous compounds. So in case of CO2, we have the exhaust of vehicles. We can burn coal to form CO2. This particular part is involved in respiration. So there are different sources of CO2 as well, but if I'm talking about the ratio of carbon is to oxygen, that will be 12:32, which is 3:8 always. It is always fixed. So their mass ratio is going to remain as it is, which shows that compound is intact and its formula is not going to change. If the formula is changing, it means compound is also changing. I hope this entire part is clear to everyone. Just look at this data carefully. Okay, next part. Question says the percentage of copper and oxygen in a sample of CuO obtained by different methods. It means different sources. Different methods means we are talking about different sources. Okay, were found to be same. So whatever the source of compound may be, their elements are always combining in fixed ratio of their mass. So which simply illustrates the law of constant composition, which is your law of definite proportion. I hope this part is clear. I hope this question is clear. Very simple question. Next part, 1.8 gram of a certain metal burned in oxygen gave 3 gram of its oxide. No issues. So we have a specific metal which is combining with oxygen to form anything. You can say, let's say I'm taking MO. It may not be MO. You can take anything, but for simplicity, I'm taking it as MO. So in this case, I'm taking 1.8 gram of this metal and 3 grams of this MO is going to be formed. It means the oxygen taken in this particular case will be 3 minus 1.8, which is 1.2 gram. Okay, so from that part I can say the ratio of M is to oxygen will be 1.8 is to 1.2. So that will be 2, yeah, 3 is to 2. So in this situation we have a 3 is to 2 ratio. Okay, this is source 1. Now we have next part. We have a source 2 in this case, which says 1.5 same metal. Okay, now the same metal heated in steam gave 2.50 gram of its oxide. Now in this situation I am forming this metal with steam to form same metal oxide. I am starting with 1.50 gram of this metal, and now we have 2.5 grams of metal oxide. So definitely if the metal is 1.5 and total metal oxide is 2.5, it means oxygen is 1 gram only. So again the ratio of M is to O will be, M is given which is 1.5 gram is to oxygen will be 2.5 minus 1.5, that is only 1 gram. So you can say this ratio will be 3 is to 2 again. So you can see whatever the source of compound may be, their elements are always combining in fixed ratio of their mass. So that shows we are talking about the law of definite proportion. Definitely. I hope this question is clear to everyone. You may not be able to find these type of questions more in NCERT because they are very easy, I can say, but sometimes it's very confusing how to apply a particular law of chemical combination in the question. So that's why we are practicing certain questions from that particular part. Now just like the constant composition or definite proportion, we have multiple proportion, because the next law is quite interesting. It may be possible by combining two elements I can form more than one type of compound. So in that situation what you have to do, the rule is going to remain same. We are talking about the ratio of the elements. In that case, let's say if I am combining two elements to form two or more than two compounds, and if I am fixing the mass of one element, then the second element's ratio is actually again whole number ratio by their mass. So it may sound slightly confusing, but I can take a very simple example related to this particular law. You can look at the statement by yourself. I am just explaining the statement in a much more simpler manner. So if you are understanding this particular part, you can write down the same statement, whatever I have given to you. Okay. So in that case, let's say I'm talking about the combination of nitrogen as well as oxygen. So I'm combining this particular part, and we know that in this situation it can form N2O, which is known as a nitrous oxide or your laughing gas. It can form nitric oxide, which is NO. It can form dinitrogen trioxide, which is N2O3. It can form dinitrogen tetroxide, which is N2O4, which is a dimer of NO2. It can also form N2O5. Okay, so these are the 5 oxides which are possible. Okay, now if I talk about the amount of nitrogen and oxygen in both the cases, nitrogens are 2, 14 multiplied by 2, which is 28 grams, and in this case oxygen will be 16 gram only. For NO it is 14 as well as 16. In case of N2O3, that is again 28 is to 48. In this case it is 28 is to 64, sorry, and this is 28 is to 80. So I told you if two elements are combining to form more than two compounds, and if I'm fixing the mass of one element, so I have to pick which element I am fixing. So let's say I'm fixing this nitrogen. This is fixed. So to fix this particular part, I need to make sure that every amount is exactly same. So we have 28, 28, 28, 28. But in this situation, we have only 14. So I am multiplying the entire part with the 2. I am multiplying the entire part with 2 so that every mass becomes 28. And now I am fixing this part. Now you can see oxygen in case of N2O is to oxygen in case of NO is to oxygen in case of N2O3 is to oxygen in case of N2O4 is to oxygen in case of N2O5. Just look at the ratio. Just look at the ratio of the same element in different compounds. You may see this is 32, sorry 16, then 32, then 48, then 64, then 80. So that will be 16 is to 32 is to 48 is to 64 is to 80, or you can write it as 1 is to 2 is to 3 is to 4 is to 5, which is again the simplest ratio by their mass. So just look at the entire data carefully. This is a very interesting law which talks about the multiple compound formation. So you can see like we are proceeding towards the chemical reaction, so we need to understand what type of compounds can be formed. So mass is going to remain conserved. They are always combining in the fixed ratio to form one compound. If they are forming more than one compounds, again this is not random, this is a highly fixed amount. And I hope this part is clear. You can take another example. You can take the example of H2O as well as H2O2. Both are the compounds of hydrogen and oxygen. In one case, hydrogen amount is 2 and oxygen is 16. In next case of H2O2, hydrogen is again 2 but oxygen is 32. Just look at the ratio of oxygen in case of H2O is to oxygen in case of H2O2. Again this is 16 is to 32, or you can say that will be 1 is to 2. Again simple whole number ratio. Next part, you can take the example of CO2 and CO and try to do it by yourself by fixing the mass of hydrogen. So here I am fixing hydrogen, here I am fixing hydrogen because both masses are 2 and 2. If this is not the case, you just have to make sure that only one element is having same type of mass so that you can fix the mass of that particular element. So that's the basic idea about the law of multiple proportions. Okay. Now question says substance A and B are colorless gases obtained by combining sulfur with oxygen. Substance A results from combining 6 gram of sulfur with 6 gram of oxygen. So in compound 1, sulfur is to oxygen is basically, or I can say sulfur amount is 6 gram, oxygen amount is again 6 gram. In compound 2, and substance B result from combining 8.6 gram of sulfur. So sulfur is 8.6 grams, okay, and this is 12.88. Oxygen is 12.88. Okay, no issues, no issues. First of all, I need to make sure that one element will be having same mass. So I can say that if I am dividing it with 6 divided by 6, that will be 1, and if I am dividing it with 6 divided by 6, that will be equals to 1. Because why I am dividing it with 6? Because I need to make sure that I have 6 gram, it means I am taking it into 1 gram part. Or you can say that 6 gram of sulfur is combining with 6 gram of oxygen. It means 1 gram of sulfur will combine with 1 gram of oxygen. Okay, no issues. In this case, you know that 8.6 gram of sulfur is combining with 12.88 gram. So you can say 1 gram of sulfur will be combining with 12.88 divided by 8.6 gram of oxygen. Now you see that 1 gram sulfur. So I am fixing this sulfur. I am fixing this sulfur. Now I can see that oxygen in case of compound 1 is to oxygen in case of compound 2 will be very easy to calculate. That will be 1 is to 12.88 divided by 8.6. Okay, so that will be I guess 8.6. So we have so 1.5, 8.6, I guess that will be 1 to 12.9 approximately, yeah. So that will be approximately 1.5. So we have 1 is to 1.5, that it means we have 2 is to 3 ratio. If this is 2 is to 3 ratio, it means this is constant. You can see simplest whole number ratio. So yes, we have the law which is multiple proportion in this particular question. I hope the entire part is clear. Very simple questions which are related to the laws of chemical combinations. Now the next law is slightly not that difficult but slightly confusing to most of the students, which is the law of reciprocal proportions. Because in this case now I am extending the compound formation. I am taking 3 elements to form 3 different compounds. So remember, in that case, let's say I am talking about 3 compounds, 3 elements. These 3 elements are combining all together to form 3 different compounds. And if I am comparing 2 compounds having one same element, okay, so I am fixing that particular element and talking about the ratio of next 2 elements in both the 2 compounds. Now I am combining these 2 elements directly to actually look at their ratio. Their ratio is going to be same or a simple whole number ratio. So simple statement is, if 2 elements combine separately with a fixed mass of a third element, okay, then the ratio of their masses in which they do so is either same or some whole number multiple of the ratio in which they are going to combine together directly. For example, I have 3 elements, carbon, hydrogen and oxygen. And carbon and hydrogen, when they combine together, they form CH4. Carbon and oxygen, when they are combining, they are forming CO2. And when these 2 elements are combining directly, they are forming H2O. Okay. So when 2 elements are combining separately with a fixed mass of third element, so I have to check the ratio of these 2 elements in 2 different compounds. Then I am combining these 2 elements directly and checking their ratio. Either this ratio is going to be same or some whole number ratio. For example, in case of a CH4, you know that carbon will be 12 gram and hydrogen will be 4 gram molar mass of CH4. Done. In case of CO2, again carbon is 12 gram and oxygen is 32 grams. So can I fix carbon because both the amounts are same? So I am fixing this particular part. Okay. Now the hydrogen which is coming from CH4 is to oxygen which is coming from CO2. Just look at their ratio. We have a 4 is to 32, which is 1 is to 8. This is the first ratio. This is the first ratio. This is the first ratio. Now, when they are combining together, so you are talking about hydrogen which is 2 gram in water and oxygen which is 16 gram in water. Now just look at their ratio. Hydrogen in H2O is to oxygen in H2O. This is 2 is to 16, that is again 1 is to 8. Now look at the ratio. This ratio when they are combining directly, this ratio when they are combining indirectly, both are same. That is the basic idea of your law of reciprocal proportion. Okay, so nothing is random in chemistry. Always elements are combining in a very specific manner. That is the actual extract of the entire law of chemical combination. Next part, you can solve it by yourself, which is the example of hydrogen, sulfur and oxygen. You can take hydrogen and oxygen when they are combining. You have hydrogen which is 2 grams, oxygen which is 16 grams. Okay, in SO2 sulfur is 32 grams, oxygen is again 32 grams. In H2S hydrogen is 2 grams and sulfur is 32 grams. So I can take hydrogen 2, hydrogen 2. So I can fix it. So I am fixing this hydrogen. So you can check the ratio of oxygen in H2O is to sulfur in H2S. That will be oxygen is 16 is to 32. This is 1 is to 2, first part. Okay. Now when they are combining directly, it means ratio of oxygen in SO2 is to sulfur in SO2, direct compound. This is 32 is to 32 which is 1 is to 1. Okay, 1 is to 1 and 1 is to 2. The ratio is again simple whole number ratio. If you are talking about they are either same. So just look at the statement. They are either same or some whole number multiple. This is whole number multiple ratio. So just try to divide this part with this part. You will get the same answer, which is 1 is to 2. So which is again simple whole number ratio. So either they are going to be same or they are again some whole number multiple of the same ratio. I hope this entire part is clear. This is your law of reciprocal proportion. Now the next part is applicable just specifically for gases, which is the Gay-Lussac's law of gaseous volumes. This Gay-Lussac's law is entirely different from the actual Gay-Lussac's law, which is in states of matter, which talks about the relation between the thermodynamic variables, pressure, volume, temperature, you know na. So we have Boyle's law, we have Charles' law, we have Gay-Lussac's law, which talks about the relation between the pressure and temperature. So this is different law. This is the Gay-Lussac's law of gaseous volumes or combining volumes, which simply say that under similar conditions of temperature and pressure, when gases combine or are being produced in any chemical reaction, they always do so in simple ratio by volume. So I am extending the application of mass into volumes, because in case of gases, volume is much more prominent in comparison to their masses. So I can simply say from that particular part that this is the equation. Now always remember, for this particular part, for the applicability of this particular part, we need balanced chemical equation. Definitely we are going to talk about balanced equation in a separate topic, but yeah, for this particular part we need balanced equation. Just a minute. Okay, so basically we need balanced chemical equation. Okay, in this particular case, if I talk about this equation, we know that H2Cl2 are already balanced, because we have 2 hydrogen on this side, 2 hydrogen on this side, 2 chlorine on this side, 2 chlorine on this side. So this is the balanced chemical equation. We will see how to balance a particular equation, definitely in this session only. Now from this particular part, you can see that one volume of H2 is going to combine with one volume of Cl2 to form 2 volumes of HCl. under the similar conditions of temperature and pressure only. If you are changing temperature or pressure, definitely this law is not going to remain as it is. Now, what is the meaning of volume? You can take any quantity, you can take in liters, you can take in ml, whatever you want, but the basic idea is that one volume of one species is going to combine with one volume of another species to form two volumes of next species, because in this case H2 is in gaseous state, Cl2 is in gaseous state, and HCl form will be in gaseous state. Just like that, we have H2 which is in gaseous state, N2 in gaseous state, ammonia is also in gaseous state. So I can say after balancing the equation, 3 volume of H2 is going to combine with the 1 volume of N2 to form 2 volume of ammonia. So that is the basic idea about the law of combining volumes or gaseous volumes. I hope this part is clear. But one thing which is for sure, that this type of law requires the balancing of the equation. Without balancing, I cannot operate on this particular law, and I need to make sure that temperature and pressure are going to remain constant. I hope this law is clear. Now let's take one question. Question says that 8 liter of H2 and 6 liter of Cl2 are allowed to react to maximum possible extent. The volume of reaction mixture will be. So from that particular part, first of all, I have to write down the equation that H2, which is in gaseous form, reacts with the Cl2, which is again in gaseous forms, to form 2HCl, which is again gaseous. So I can say that one volume of this particular part reacts with one volume of this to form 2 volume of the product. Now we have 8 liters of this, 8 liters of H2 and 6 liters of Cl2. So I can say that 6 liter is going to react with 6 liter of H2 completely. So after the reaction, we will left with 2 liter here, and it is going to be completely consumed because the 6 liter is going to combine with 6 liter. So I can say that 6 liter of Cl2 reacts completely with 6 liters of H2 to form 12 liters of HCl according to the same law. So I can say that it is going to be form 12 liter. Now after the complete reaction, the reaction mixture will contain HCl as well as some amount of H2 which is left. So HCl formed is 12 liter, H2 left is 2 liter, that will be equal to 14 liter. That is the final amount of the reaction mixture. So you can say the correct answer is going to be option number C. I hope this entire part is clear to everyone. Just look at the data. You will left with 14 liters of the reaction mixture. Okay. Now talking about the next part. Now we know the importance of chemical equation, because for the applicability of combining volumes or the gaseous volumes law, we need the balancing of chemical equation. But what is chemical equation? So let's say I am talking about a chemical change, that I have taken coke and I am burning the coke in air to form carbon dioxide, and if there is any chance that coke contains certain amount of hydrocarbon, then it is going to form H2O also. Let's say I'm talking about this particular part. Now how you are going to represent that particular chemical change in the form of equation, that representation to actually express the chemical reaction or chemical conversions with the help of their symbols as well as their formulas is actually known as your chemical equation. So the representation of a chemical change in terms of their symbol and formula is actually known as chemical reaction. I hope this definition is clear to everyone. Very simple definition, very simple definition. Okay, so this is the entire part related to your chemical equation. Now let's say I'm talking about, I'm mixing silver nitrate with sodium chloride. Now both the solutions are actually transparent. When I'm combining these two together, how can I say the chemical change is happening? By simply seeing their color change. So when I'm combining sodium chloride aqueous solution with silver nitrate aqueous solution, just when I'm mixing these two parts, they are going to form white turbidity. So I can simply see that chemical change is happening. So how can I represent this particular part? We know that sodium chloride is having formula which is NaCl. Okay, next part is a silver nitrate is having formula which is AgNO3, When I'm combining these two together, definitely a chemical change is going to happen which forms sodium nitrate aqueous solution. But again, the white turbidity appears due to the presence of insoluble AgCl, which is silver chloride. Now this entire representation is actually known as chemical equation. But chemical equation is not sufficient. We need to balance that particular part to extract the actual information. So that we can apply the law of gaseous volumes, as well as we can apply the concept of stoichiometry. So I am introducing the concept of stoichiometry in this particular part. Now I can say, let's talk about another equation which is a very common equation, that I am combining methane with oxygen to form CO2 as well as H2O. So I can write it as this methane, which is CH4, is combining with oxygen to form carbon dioxide as well as water. Now if you look at this equation, definitely this is the chemical equation. This is your chemical equation. Definitely this is your chemical equation. But from that part I can say that on LHS side, which is the reactant side, so these are the reactants, this is the product. What is the meaning? Reactants are the species which are involved in the chemical change, and product is basically, or products are the species which are formed after the chemical change. Okay, so and LHS side you can see carbon is actually 1, hydrogens are actually 4, and oxygens are actually 2. In this case, on right hand side you can see that carbon is 1, but oxygens are 3 and hydrogens are only 2. So you can see their number is not same. It means we cannot apply the law of conservation of mass. We cannot apply any law of gaseous volumes. So if we cannot apply, we need to make sure that these laws can be applied very easily. So we have to balance this equation. So this particular part is known as unbalanced chemical equation, which is of no use. Always remember, if you have unbalanced chemical equation, it has no meaning. But if I am solving this entire part, if I am balancing this equation, I can put 2 in front of O2 and 2 in front of H2O. Now these two are actually known as coefficient, or also known as stoichiometric coefficient. These are also known as stoichiometric coefficients. Definitely we are talking about the concept of stoichiometry. Now after we are putting the stoichiometric coefficient, we can say we have CH4 plus a 2O2 gives us a CO2 as well as 2H2O. Now you can count the LHS side. In this case, carbon is 1, hydrogens are 4, and oxygens are also 4. 2 2s are 4. On RHS side, now you can say carbon is 1, oxygen is 2 here and 2 here, so total 4, hydrogens are also 4, 2 2s are 4. So you can see both the atoms are exactly same on both the sides. It means this is your balanced chemical equation, which is much more relevant, because now I can extract the information that one molecule of CH4 is going to combine with the 2 molecules of O2 to form 1 molecule of CO2 and 2 molecules of H2O. Or I can say that 1 mole of CH4 is going to combine with 2 moles of O2 to form 1 mole of CO2 and 2 moles of H2O. I hope this entire part is clear. This is the most important portion related to the concept of stoichiometry. So what is the meaning here? Meaning is very easy. To balance the chemical equation, a number is placed in front of chemical formula, either the reactant side or the product side. And this coefficient we all know is known as stoichiometric coefficient. So basically, stoichiometry actually deals with the calculation of mass, volume, moles of reactant and product involved in the chemical equation. I hope this part is clear. Very interesting portion. So first of all, we need to understand how to balance a particular chemical equation, then only we can proceed for the next part. Okay, so to understand the entire part, let's talk about a simple question first. So for the given reaction, the values of x, y, z will be, and this we know that this is the unbalanced equation. We have to know about the x, y and z value. Now in this case, you have 3 carbon here, 8 hydrogen, then we have x number of oxygens, then we have y number of carbon, O2, Z, whatever it is. So I am not writing this x, y, z, I am writing just as C3H8 plus O2 gives us CO2 plus H2O. Now this equation is unbalanced equation because carbons are 3, carbon is 1. So first of all, remember what we have to do. We have to balance atoms other than hydrogen and oxygen. First balancing will be done for all the atoms other than hydrogen and oxygen. Then you can pick the balancing of hydrogen or oxygen depending upon the situation, and this is hit and trial method, because in these type of reactions, which is the balancing of simple chemical reaction, there is no specific law. But in case of redox reactions, we have certain laws, ion electron method as well as oxidation number method, but in this case you have to use the hit and trial method. Okay, now for this situation I can say 3 carbons are intact. It means I have to multiply the entire situation with 3. Now in this case only hydrogen is intact with this C3H8. In this case you cannot see hydrogen, so first try to balance hydrogen. So 8 means I am multiplying it with 4. 4 2s are 8. Now you can see carbon is balanced, hydrogen is balanced, because carbon in this side is 3, hydrogens are 8. Carbon in that side is again 3 and hydrogen is actually 8 in number. So this part is actually balanced. Now just look at the oxygen. 3 2s are 6 plus 4, total 10. It means I am multiplying it with 5. 5 2s are 10. Now you can see oxygens are 10 on this side, oxygens are 10 on this side. Now this equation is a balanced chemical equation. Now compare this equation with this particular part. You can see that x value will be equal to 5, first part, y value will be equal to 3, and z value will be equal to 4. So after comparing this equation with this equation, you can see x is 5, y is 3, and z is actually 4. I hope this entire part is clear. I hope you remember the balancing. Try to balance some more equations by yourself, so that you'll gain the confidence to balance a particular equation, because balancing is always required whenever we are dealing with the concept of stoichiometry. Okay. Now the next part is when ammonium dichromate is heated, then. Now these are the situations where everything is unknown, but you know about this particular part, ammonium dichromate. Okay, so one thing I want to ask you, if you want a separate lecture, if you want a proper lecture how to determine the formula of compound, how we can find out the product of an unknown reaction, then just let me know in the comment box. I'll give you one lecture related to the entire part where you know how to deal with the unknown formulas, how to deal with the product formation in any of the unknown reaction, because this is the most confusing part. Most of the students are stuck in this situation, like, sir, we don't know how to write the formula. We are very confused in the formulation part. We are very confused like how to predict the product in the reaction, because most of the reactions are different. So definitely I'll help you out with this particular part, but let me know in the comment box if you want that particular lecture. Sir, we need that lecture dedicatedly to know about the formula of compound as well as to know about the actual reaction prediction. Okay, so definitely I'll provide you that. Okay, so when ammonium dichromate, so we have ammonium which is NH4 positive, dichromate is Cr2O7 2 negative. So just cross multiply their charges, you will get the formula as NH4 twice Cr2O7. Now this reaction is a thermal decomposition, is heated. So whenever this term is given, always remember we are talking about the thermal decomposition. So this is one of the type. Okay, in thermal decomposition, whenever there is a question related to thermal decomposition and you can see hydrogen and oxygen in the compound, try to remove water first, because whenever you are heating, water is going to remove immediately. So in this case, you can see hydrogen, you can see the oxygen. How many water molecules you can remove? Just look at the hydrogen. You have a 4 to the 8 hydrogens and 7 oxygens. So if I talk about H2O, there are 8 hydrogens. How many water you can remove? You can remove 4 water molecules. 4 water means again 4 to the 8, 8 hydrogens. So you can remove 4 H2O first of all. So in thermal decomposition, if you have hydrogen and oxygen, just try to remove a first number of H2O possible. So 8 hydrogens means I can remove 4 H2O. Now this part is gone. This part is gone. Now you are left with 3 oxygens only, 3 oxygens. Cr2 and 3 oxygens means you have Cr2O3. Oh sir, this is a new trick. Now remaining part is 2 nitrogens are also left. So you can say we have N2 left. Okay, now just look at the equation. It is already balanced. It is already balanced. So we are talking about the balanced chemical equation. Very good, very good. No issues in this case. So you can see that when 1 mole of this ammonium dichromate is heated, it's going to form 4 moles of H2O. So this part is incorrect. We have 4 moles of H2O. 1 mole of Cr2O3 is going to be formed. Definitely true. Definitely true. 2 moles of N2 is formed. Definitely incorrect. And 1 mole of O2. Are O2? O2? There is no O2. So no O2 will be formed. So now for your practice, try to solve the decomposition of, let's say, ammonium nitrite, thermal decomposition of ammonium nitrite. Let's try this. So ammonium is again NH4 positive, nitrite is NO2 negative. Combine the formula. You can see the formula will be NH4 NO2. Thermal decomposition. Again I am looking for the hydrogen and oxygen. 4 hydrogens are present. It means I can remove 2 H2O. So I have removed 4 hydrogens, gone. 2 oxygen, gone. Remaining part is nitrogen, nitrogen. So you will left with only one product, which is N2. Oh ho ho! Excellent, excellent. Okay, next part. Let's say I'm talking about the thermal decomposition of ammonium nitrate. Ammonium nitrate, thermal decomposition. Ammonium is again NH4 positive, nitrate is NO3 negative. Combine the formula. You have NH4 NO3. Thermal decomposition, sir, I can see hydrogen and oxygen. Remove as many water molecules as possible. That depends upon the number of hydrogen. So I have 4 hydrogens. So I can remove 2 H2O. So 2 H2O gone. Now you are left with 2 nitrogens. Sir, I can see 2 nitrogens here and 1 oxygen left. It means you have N2O. Okay. I hope this part is clear to everyone. This part is clear. Okay, and that's how you can predict the reaction. This is the type of thermal decomposition. Okay, now the next part, how can we extend this information? We know about the chemical equation, we know about the balancing of chemical equation, we know the information to extract, but for unknown reaction, how can we proceed for the question? So in mole analysis, we are dealing with the first part. If the data of only one reactant or product is given. When the data of only one reactant and product is given, then how can we proceed for this type of reaction? So let's take an unknown reaction. I don't know about the actual reaction. Let's take an unknown reaction. AA plus BB gives us CC plus DD. This is the most complex reaction. We don't know anything, but we know that small a, small b, small c and small d are the stoichiometric coefficient of this equation. And this equation I am already giving you as a balanced chemical equation. Okay, I hope this part is clear. I hope this part is clear. Now you can say that number of moles of A divided by its stoichiometric coefficient will be equal to number of moles of B divided by its stoichiometric coefficient will be equal to number of moles of C divided by its stoichiometric coefficient will be equal to number of moles of D divided by its stoichiometric coefficient. Always remember, this is the mole analysis, nothing fancy. I'm not going to use any term. You can convert mass into mole, then mole analysis. You can convert moles into mole analysis. You can convert mole into mass analysis. Nothing fancy. Whatever information is given to you, try to convert that information into moles. So first part, what you have to do, look at the balanced chemical equation. If not given, then balance the equation. If not given, then balance the equation. Now let's say this part is done. This part is done. Next part, convert whatever information is given to you into number of moles. Whatever information is given to you, convert that information into number of moles. Third part, what can we do? What can we do? Very easy. If you know that we have converted the entire part into number of moles, apply mole analysis. But this application is not clear till now because we have everything unknown to us. Let's try to do the same part with the known questions. Okay. So let's say we have first question. How many gram of HCl is needed for complete reaction with 69.6 gram of MnO2? So you know, first of all, the data of only one part is given. The data of one part is given. And the question is asking about the next part. So we can apply mole analysis. Now in this case, is this the balanced chemical equation? I can see that HCl 1H 2H. No, this is not the balanced chemical equation. So first of all, we have to balance this equation. So Mn balanced. And in this case 2Cl means 4Cl. So I am multiplying it with 4, or I can write it here that we have a 4HCl plus MnO2 gives us MnCl2 plus Cl2 plus H2O. Now chlorine is balanced, 4 hydrogens means multiplied by 2. Now this is done. So step 1 is done, which is balanced chemical equation. Okay, this is done. Now second part I can say, second part is calculate number of moles. Calculate number of moles. So I can say that information about only one reactant is given, means the question is from mole analysis. Definitely the question is from mole analysis. So number of moles of MnO2 will be equal to W of MnO2 given divided by the molar mass of MnO2. Okay, so let's say the Mn has mass which is 55, let's say, because it's not given, we can take it as 55. So 55 plus 32, 55, 57 and 87, approximately 87. So that will be 87. So 69.6 divided by 87. Okay, so 69.6 divided by 87. Okay, this part is already known. Now third part is mole analysis. So I can say that number of moles of MnO2 reacted divided by its stoichiometry is 1 will be equal to number of moles of HCl divided by its stoichiometry, which is 4. So I can say from that part that number of moles of HCl are basically 4 multiplied by number of moles of MnO2. So can we calculate this information? Yes, very easily, sir. We have n number of moles of MnO2 which we have already calculated, multiplied by 4. Now the question is asking about the grams. So from that part I can use additional concept that number of moles of HCl are equal to W of HCl divided by molar mass of HCl. So I can say W of HCl will be equal to number of moles of HCl multiplied by 36.5, and that's how you can calculate the entire part. Just put the value in this equation and let me know the final answer. Okay, I hope this entire part is clear to everyone. This entire part is clear. Very simple question, the entire application is clear, and that's how we can deal with the questions related to mole analysis. Okay, let's talk about another question. Okay, this question is from NCERT itself, same type of question basically. So I am giving this question as your homework, so you can do it by yourself. Question says chlorine is prepared in the laboratory by treating manganese dioxide MnO2 with aqueous hydrochloric acid according to the reaction. Now this equation, if you look at this equation, you already know that this is the balanced chemical equation already given to us. Now how many grams of HCl react with 5 gram of manganese dioxide? Same type of question in different manner. Same type of question. What you can do? First of all, calculate the number of moles of MnO2 divided by its stoichiometry will be equal to number of moles of HCl divided by its stoichiometry. From that part, number of moles of HCl are basically 4 multiplied by number of moles of MnO2. Then expand this formula, that will be equal to W of HCl divided by molar mass of HCl will be equal to 4 multiplied by number of moles of MnO2, and you can say W of HCl will be equal to 4 multiplied by number of moles of MnO2 multiplied by 36.5. Okay, and that's how you will get your answer very easily. So the same application you can apply for this question also. Okay, there is one another method by which you can solve these type of questions, which is basically the unitary method. So you know that that 1 mole MnO2 reacts with 4 mole HCl. Another method. Okay, so this is another method. Those who want to solve this question by unitary method, so I am giving this particular part, that 1 mole of MnO2 reacts with 4 moles of HCl. So 1 mole means we have 87 grams of MnO2 reacts with 4 multiplied by 36.5 grams of HCl. So molar mass of HCl is 36.5. 4 moles means 4 multiplied by 36.5. So I can say that will be equal to 35.5 multiplied by 212 73, I guess 36 72, yeah, 73 multiplied by 2 146. So that will be, I can say that 87 gram of MnO2 reacts with 146 gram of HCl. It means 1 gram MnO2 reacts with 146 divided by 87 gram of HCl. So 5 gram will react with, 5 gram of MnO2 will react with 146 by 87 multiplied by 5 gram of HCl. So you can do it by another method also, which is unitary method, and you can use it with the mole analysis part also. I hope the entire part is clear to everyone. Very simple question, very simple analysis. Now next part is quite interesting, and this is the most important one. Just remember, this is the most important one. That is the concept of limiting reagent. Now, how to differentiate between mole analysis and limiting reagent? The idea is very simple. Now, in this case, in question, if the data of all reactants is given Because in the previous case of mole-mole analysis, we were only dealing with the data of one reactant or one product, and we are using the same correlation to calculate the entire part. But in this case, if the question says that we have, let's say, two reactants and the data of both the reactants are given, that X gram of this reactant reacts with Y gram of that reactant to form a product. So in that case, we need to understand that additional concept will be there, which is the limiting reagent concept. Limiting reagent concept is very easy. I am going to use a very simple analogy. Let's try to make hot dog sandwiches. So let's say you can take any McD sandwich or whatever it is, Subway sandwich, whatever you want to make. So let's say today we are making in the cooking class we are making hot dog sandwiches, and I'm starting with some hot dogs and some buns. So I can say these hot dog as well as these buns, they are basically reactant. These are basically reactant, and after that I am putting the hot dog in bun and I am heating it, I am grilling it, and definitely I'll get the hot dog sandwich. So this hot dog sandwich is basically my final product. Now the quantity. Let's say I have started with 5 hot dogs and 4 buns. So you can see the data of both the reactant is given, that we have 5 hot dogs and 4 buns. In this case, you can see that one bun can only form one sandwich. So we have 4 buns. So definitely 4 sandwiches are going to be formed. It means the product formation depends upon the reactant which is lesser in amount. So that particular reactant which is less in amount and which is going to limit the product formation is actually known as limiting reagent in terms of chemistry. And the reagent which is present as a leftover, which is not going to be consumed completely, is known as the excess reagent. And in this analogy, we have hot dog which is leftover, which is the excess reagent. I hope this simple terminology is clear to everyone, and how to differentiate the questions of mole-mole analysis with limiting reagent. Now in terms of chemistry, let's say we have a chemical reaction. Although this was the animation, but currently I have put it in PDF, so the animation is not working. So basically you can see 2 bulbs, and in 2 bulbs one side we have NO gas and on another side we have O2 gas. So I'm starting with the reactants which are NO as well as O2. Now if this question is from mole-mole analysis or limiting reagent, let's find out. The data of NO and O2 both are given, that we are starting with 6 moles of NO with 2 moles of O2. So you know definitely this question is from limiting reagent. So in the animation there was some reaction was happening, and after that you can see only 4 moles of NO2 are going to be formed and 2 moles of NO are going to remain as a leftover. So for that part I am writing this equation, that 2 NO when combines with O2 to form 2 NO2. It means 2 moles of NO always combines with 1 mole of O2 to form 2 moles of NO2. So we have 2 moles of O2. So I can say if we have 2 moles of O2, they can combine with 4 moles of NO to form 4 moles of NO2. But initially we have taken 6 moles of NO2. If we have taken these 6 moles of NO2, if we have taken these 6 moles of NO2, it means, what is this? Okay, sorry. So if we have 6 moles of NO, I can simply say only 4 moles are reacted. It means in this particular situation, I can say that NO is the excess reagent, because after the completion of the reaction, you will left with the 2 moles of NO and O2 is completely consumed. It means in this situation, O2 is the limiting reagent. But sir, this particular part is clear to us. Sir, this demonstration is very clear to us. But in question, how can we deal? How can we find out which one is limiting reagent? So idea is very easy. Very easy. You just have to follow 3 simple steps. First of all, you need balanced chemical equation, because the question is from mole-mole analysis only. The question is from mole-mole analysis only. Okay. Next part, you have to convert all the given information into moles. You have to convert the entire information into moles. Whatever, it may be directly given into moles, it may not be directly given into moles. So you know, we have the formula of moles: given weight divided by molar mass, first formula. Next formula is number of particles divided by Na, second formula. Volume of gas in liters at STP divided by 22.4 liters. So you can use any of the formula to convert the information into number of moles. And you have the balanced chemical equation. It means you know about the stoichiometric coefficients. You know about the stoichiometric coefficients. So what you have to do? You just have to divide the number of moles with their stoichiometric coefficient. The lower value will give you limiting reagent. That's all. That's all. Okay. Now try to apply the entire part in the same equation, which is this part. So we have the equation that 2NO when combines with O2, they are going to form 2NO2. Now number of moles of NO are already given, which are 6. Number of moles of O2 are given, which is basically 2 in this case. So I can say for the limiting reagent, I have to divide number of moles by stoichiometry, which is 3. For limiting reagent calculation, I have to divide number of moles by stoichiometry, which is 2. The lower value will give you the idea about limiting reagent. So this particular part is your limiting reagent. Very easy, very easy. Definitely it's going to be consumed. Now if this is consuming, this is going to predict the product formation. So I can apply the second part. Now to solve this question, I can again use, after the calculation of limiting reagent, now I can use mole analysis. I hope this entire part is clear. This is the simplest part related to the limiting reagent calculation. But this part is not clear, sir. We need certain questions to practice. So definitely I have certain questions for your practice part. Okay. Question says carbon reacts with chlorine to form CCl4. 36 gram of carbon was mixed with 142 gram of chlorine. Calculate mass of CCl4 produced and the remaining mass of reactant. Now you can see the data of both the reactants are given. It means the question is from limiting reagent. So first of all, I have to write down the equation that carbon when reacts with Cl2, it is going to form CCl4, which is carbon tetrachloride. Now this equation is not balanced because we need the balanced equation. I can multiply it with 2. Now the equation is balanced. So we have the first part, which is balanced chemical equation. Okay. Second part is W of carbon is given, which is 36 gram. W of a Cl2 is given, which is 142 grams. Can we calculate the moles? Number of moles of carbon are given weight divided by its molar mass, which is 3. Number of moles of a Cl2 given weight divided by molar mass, which is 71, that is 2. Next part, calculation of limiting reagent. Number of moles divided by stoichiometry of carbon, which is 1. So 3 divided by 1 gives us 3. For the calculation of limiting reagent, number of moles of chlorine divided by stoichiometric coefficient, which is 1 only. Now you know that Cl2, this is the lower value, this is the lower value. If this is the lower value, it means I can say that Cl2 is limiting reagent. Cl2 is limiting reagent. Cl2 is limiting reagent. If a Cl2 is limiting reagent, I can apply mole analysis using this part. How can I apply mole analysis? It's very easy. It's very easy. Because we were applying the mole analysis in the initial part. So I can say number of moles of Cl2 divided by its stoichiometry will be equal to number of moles of CCl4 divided by its stoichiometry. This part we already know. We have calculated 2 divided by stoichiometry from the equation 2. So we can say that number of moles of CCl4 will be equal to only 1. If we know the number of moles, we know that W of CCl4 will be equal to number of moles multiplied by molar mass of CCl4. That will be equal to this is 142, then 142, 144, 154. That will be 154 grams. That's it. That's it. Now the next question is, and the remaining mass of the reactant. So again I have to apply the mole-mole analysis. Again I have to apply the mole-mole analysis, because if I want to know about the reactant left, then I need to calculate the total amount of reactant minus amount which is reacted. Then only I can talk about the reactant which is left. So for that part, again I have to apply the mole-mole analysis. So I can say that number of moles of Cl2 divided by its stoichiometry will be equal to number of moles of carbon which is reacted divided by its stoichiometry. From that part, I can again say that number of moles of carbon reacted will be equal to 1, because 2 divided by 2 is equal to 1. From that part, I can say that W of carbon which is reacted will be 12 gram only. I am writing the direct formula, because number of moles are W of carbon divided by molar mass. Molar mass of carbon is 12. So 1 multiplied by 12 will be equal to 12 gram. Now you know that W of carbon left will be W of carbon which is total minus W of carbon which is reacted. So total was 36, reacted is 12, that is left is 24 grams. I hope this entire calculation part is clear. It will take certain some amount of time to understand the entire part and to solve the question by yourself. Okay. But this is the easiest way possible to deal with the questions of limiting reagent. I hope that entire part is clear to everyone. And this is the question from your NCERT. Dinitrogen and dihydrogen react with each other to produce ammonia according to the following chemical equation. Definitely the equation is balanced chemical equation or not. No, this is not the balanced chemical equation. I have to put it N2 plus 3H2. This is 3H2 gives us 2NH3. Calculate the mass of ammonia produced if 2 multiplied by 10 raised to the power 3 gram of dinitrogen reacts with 1 into 10 raised to the power 3 gram of dihydrogen. Means the concept of limiting reagent, because the data of both the reactants is given. Just let me know the answer. Will any of the two reactants remain unreacted? That we have to find out if there is any limiting reagent or not. If yes, which one and what would be its mass? So you know how to deal with the calculation. I am giving this question as your homework. Okay, so this is your homework. Just do it by yourself. Okay. Next question, in a reaction A plus B2 gives AB2, identify the limiting reagent if any in the following reaction mixture. So you know the rule, how to find out the limiting reagent. So I can say from this equation that we have A plus B2 gives us AB2. It means one atom of A completely reacts with one molecule of B2. This is the information, that one atom of A is going to be completely reacted with one molecule of B2 to form one molecule of AB2. Okay. Now in this situation you have 300 atoms of A. It means 300 atoms of A actually requires 300 molecules of B2. But the given information is only 200 molecules. It means you know that this amount which is given to you, given is only 200 molecules. If it is 200 molecules, you know that this is the limiting reagent. So you can say from that particular part that this B is going to be limiting reagent, and that's how you can calculate the entire part. Okay. So I am giving the remaining part as a homework. If you find any difficulty, definitely we will discuss that part. This question is again from your NCERT, the question of limiting reagent. Okay. So, okay, next question is, under appropriate conditions, the reaction of elemental phosphorus and elemental sulfur produces the compound P4S10. How much P4S10 can be prepared starting with 10 gram of P4 and 30 gram of S8? So, first of all, you have to write down the equation. So, I am giving you some hint. So, this is the hint part. You have P4 plus S8 gives us P4S10. Okay. This is not the balanced equation. So, what we have to do? We can say that will be 5 by 2. P4 balance, 10 means 10 by 8, 5 by 4. So, this is 4, this is 5, this is again 4. Now, we have the balanced chemical equation. Okay. Now, is this question from limiting reagent? Yes, because the data of both the reactants is given. It means the question is from limiting reagent. Okay, you have to use the limiting reagent concept for this question. What can you do? This data is given that W of P4 is given, which is 10, W of S8 is given, which is 30. Number of moles of P4 are basically 10 divided by 4 multiplied by 31. P4 means phosphorus has 31 mass, 31 multiplied by 4, which is 124, and number of moles of S8 are basically 30 divided by 8 multiplied by 32. Now you know the stoichiometry. So divide these number of moles with their stoichiometry, divide this number with the stoichiometry, you will get the answer which one is lower value, that will be your limiting reagent, and apply mole analysis. Okay, I guess the options are incorrect, so just forget about the options. These are not relevant right now because they are from different question. Okay, typo error. Okay, just don't look at this particular part, or okay, I'll try to remove this. No information is given, because I know you might be confused. Sir, these options are not matching. What to do in that situation? So I am removing the options for you guys. So just try to solve the equation by yourself. Okay. So I guess that's it. That's it. So don't look at the options, and that's all from my side. So we have discussed most of the concepts in this particular session. In next or last session, I can say, we are going to discuss about the concentration terms. That is only thing which is left, and I'll try to make sure that we will practice enough questions related to the concentration terms as well as this limiting reagent part, so that you will get the confidence to solve those questions by your own. Okay, but try to solve all the questions which I have given you in the homework, and definitely we'll meet in the next class to discuss the remaining portion. Okay, so that's all from my side. Thank you so much.